Uh, Jakarta Mail, formerly JavaMail Architecture. This is the layered architecture diagram for Jakarta Mail. Jakarta Mail, formerly JavaMail, is a Jakarta EE API used to send and receive email via SMTP, POP3 and IMAP. Jakarta Mail is built into the Java EE platform but also provides an optional package for use in Java SE. Here you can see a different diagram of architecture of Java Mail. JavaMail is designed to standardize access to a variety of email services. The JavaMail architecture provides a protocol-independent access for sending and receiving messages. This abstract mechanism is similar to other Java J2EE APIs such as JDBC, JNDI, and JMS. Similarly, the JavaMail API is divided into two main parts: an application independent part and service dependent parts. Your applications are written in a standard way to use the application independent part of the JavaMail API, which transparently calls the underlying protocol or email service. A JavaMail compliant service must implement part of the JavaMail API. Here is a brief description of the two parts that comprise JavaMail architecture. Here an application programming interface API. This API is used by the application components to send and receive mail messages independent of underlying provider or protocol used. A service provider interface. This part of the API speaks the protocol specific languages such as SMTP, POP, IMAP, and Network News Transfer Protocol, NNTP. It is used to plug in a provider of an email service to the J2EE platform. This figure illustrates the JavaMail architecture and interaction of the two main APIs. Here SMTP, the Simple Mail Transfer Protocol, SMTP, is an internet standard communication protocol for electronic mail transmission. Mail servers and other message transfer agents use SMTP to send and receive mail messages. User-level email clients typically use SMTP only for sending messages to a mail server for relaying and typically submit outgoing email to the mail server on port 587 or 465 per RFC 8314. For retrieving messages, IMAP, which is replaced the older POP3, is standard, but proprietary servers also often implement proprietary protocols. For example, Exchange ActiveSync. IMAP, Internet Message Access Protocol. In computing, the Internet Message Access Protocol, IMAP, is an Internet standard protocol used by email clients to retrieve email messages from a mail server over a TCP IP connection. IMAP is defined by RFC 9051. Post Office Protocol. In computing, the Post Office Protocol POP is an application layer Internet standard protocol used by email clients to retrieve email from a mail server. POP version 3, POP3 is the version in common use, and along with IMAP, the most common protocols for email retrieval. Here you can see a Java application, mail enabled application interacts with JavaMail API. JavaMail API interacts with JavaMail SPI server protocol layer. JavaMail SPI server protocol layer interacts with protocol implementations. SMTP, IMAP, IMAP, and POP is inside protocol. SMTP, IMAP, and POP are inside protocol implementations. Now we are focusing on mail enabled application. Mail enabled application. Jakarta Mail uses Jakarta activation in order to encapsulate message data and to handle commands intended to interact with that data. Interaction with message data should take place via JAF aware Java beans, which are not provided by the Jakarta Mail API. Here you can see Jakarta Activation 2.0 architecture. The Java platform, including Java Beans, already provides some support for a modest activation framework. Jakarta Activation leverages as much of that existing technology as possible. Jakarta Activation integrates these mechanisms. This diagram shows the major elements comprising the Jakarta Activation architecture. Note that the framework shown here is not bound to a particular application. Data handler class. The data handler class shown in this diagram here provides a consistent interface between activation-aware clients and other subsystems. The data source interface. The data source interface encapsulates an object that contains data and that can return both a stream providing data access and a string defining the MIME type describing data. Classes can be implemented for common data sources, web, file system, IMAP, FTP, etc. The data source interface can also be extended to allow per data source user customizations. Once the data source is set in the data handler, the client can determine the operations available on that data. Jakarta activation includes two data source class implementation for convenience. File data source accesses data held in a file. URL data source accesses data held at a URL. Command map interface. The command map provides a service that allows consumers of its interface to determine the commands available on a particular MIME type, as well as an interface to retrieve an object that can operate on an object of particular MIME type, effectively component registry. The command map can generate and maintain a list of available capabilities on a particular data type by a mechanism defined by the implementation of a particular instance of a command map. The JavaBeans package provides the programming model for the software components that implements the commands. Each JavaBeans component can use externalization or can implement the command object interface to allow the type data to be passed to it. Jakarta activation defines the command map interface, which provides a flexible and extensible framework for the command map. The command map interface allows developers to develop their own solutions for discovering which commands are available on the system. A possible implementation can access the type registry on the platform or use a server-based solution. Jakarta activation provides a simple default solution based on RFC 1524 .mailcap like functionality. The command object interface. Beans extend the command object interface in order to interact with activation services. Activation-aware JavaBeans components can directly access their data source and data handler objects in order to retrieve data type and to act on the data. Data content handler interface. The data content handler interface is implemented by classes that are used by the data handler to convert input stream into objects and vice versa. In effect, the data handler object uses a data content handler object to implement the transformable interface. The data content handlers are discovered via the current command map. A data content handler uses data flavors to represent the data types it can access. The data content handler also converts data from objects into input streams. For instance, if an application needs to access a .gif file, it passes the file to the image GIF data content handler. The image GIF data content handler converts the image object into a GIF formatted byte stream. Applications will typically need to provide data content handlers for all the MIME types they intend to support. Note that the Jakarta Mail implementations provide data content handlers for many of the MIME types used in mail messages. Here you can see the framework client here. Framework clients interacts with data source. Framework client interacts with data handler. Data source is connected to data handler. Data handler interacts with data content handler. Data handler interacts with command map. Command map is connected to command object. Now we are focusing on Java Bean used to interact and display message content. The beans of Java Beans are classes that encapsulate one or more objects into a single standardized object, the bean. This standardization allows the beans to be handled in a more generic fashion, allowing easier code reuse and introspection. This in turn allows the beans to be treated as software components and to be manipulated visually by editors and IDEs without needing any initial configuration or to allow or to know any internal implementation details. Java Bean used to interact and display message content. As an example, we can consider this code segment. Consider a message viewer bean that represent a user interface that displays a mail message. This example shows how a viewer bean can be used to display the content of a message that usually text plain, text HTML or multi-part mixed. Method getBean commanding for a convenient method that takes a command info object and instantiate the corresponding command, usually a Java Bean component. Now we are focusing on Jakarta Mail API. The Jakarta Mail API provides classes that model a mail system. The Jakarta.mail package defines classes that are common to all mail systems. The Jakarta.mail.internet package defines classes that are specific to mail systems based on internet standards such as MIME, SMTP, POP3, and IMAP. The Jakarta Mail API includes the Jakarta.mail package and subpackages. This figure shows major classes and interfaces comprising the Jakarta Mail API. The message class is an abstract class that defines a set of attributes and content for a mail message. Attributes of a message class specify addressing information and define the structure of the content, including content type. The content is represented as a data handler object that wraps around the actual data. The message class, the part interface defines a set of standard headers common to most mail systems, specifies the data type assigned to data comprising the content block, and defines set and get method for each of these members. It is the basic data component in Jakarta Mail API and provides a common interface for both message and body part classes. The body part class is an abstract class that implements the part interface in order to define the attribute and content of the body. Attribute and the content body definitions that part declares. It does not declare attributes that set from, to, subject, reply to, or other address header fields as a message object does. A body part object is intended to be inserted into a multi-part container. Later access via a multi-part message. The Jakarta Mail MIME part interface models an entity as defined in RFC 2045 section 2.4. MIME part extends the Jakarta Mail part interface to add MIME specific methods and semantics. The MIME message and MIME body part classes implements the MIME part interface. MIME message class. The MIME message class extends message and implements MIME part. This class implements an email message that conforms to the RFC 822 and MIME standards. MIME body part class. The MIME body part class extends body part and implements the MIME part interface. This class represents a part inside a multi-part. MIME body part implements a body part as defined by RFC 2045 section 2.5. Here you can say a part interface and MIME part interface, and message class, body part class, MIME body part class, and MIME message class, and multi-part container class is here, and MIME multi-part container class here. You can see part interface here. MIME message class extends message class. Message class implements part interface. MIME message implements MIME part interface. MIME body part class implements MIME part interface. MIME part interface extends part interface, and MIME body part extend body part class. Body part class implements body part interface. MIME body part class is inside MIME multi-part container class. Body part class is inside multi-part container class. MIME multi-part container class extends multi-part container class. MIME part interface, MIME message class, MIME body part class, and MIME multi-part content interface class are inside Java implementation layer. This figure illustrates the Jakarta Mail message handling process. The Jakarta Mail API is intended to perform the following function, which comprise the standard mail handling process for a typical client application. Create a mail message consisting a collection of header attributes and a block of data of some known data types as specified in the content type header field. Jakarta Mail uses the part interface and the message class to define a mail message. It uses JAF defined data handler object to contain data placed in the message. Create session object which authenticates the user and control access to the message store and transport. Send the message to its recipient list. Retrieve a message from message store. Execute high-level command on a retrieved message. High-level commands like view and print are intended to be implemented via activation or via Java beans. Jakarta Mail framework does not define mechanisms that support message delivery, security, disconnected operation, directory services, or filter functionality. Uh, the message class is an abstract class that defines a set of attributes and a content for a mail message. Attributes of the message class specify addressing information and define the structure of a content, including content type. The content is represented as a data handler object that wraps around actual data. The message class implement the part interface. The part interface defines attributes that are required to define and format data content carried by the message object and to interface successfully to a mail system. The message class adds from, to, subject, reply to, and other attributes necessary for message routing via a message transport system. When contained in a folder, message object has a set of flags associated with it. Jakarta Mail provides message subclasses that support specific messaging implementations. The content of a message is a collection of bytes or a reference to a collection of bytes encapsulated within a message object. Jakarta Mail has no knowledge of the data type or format of the message content. A message object interacts with its content through an intermediate layer, Jakarta activation. This separation allows a message object to handle any arbitrary content and to transmit using any appropriate transmission protocol by calls to the same API methods. The message recipient usually knows the content, data type, and format, and knows how to handle that content. Jakarta Mail API also supports multi-part message objects where each body part defines its own set of attributes and content. Message storage and retrieval. Messages are stored in folder objects. Folder objects can contain subfolders as well as messages, that thus providing a tree-like folder hierarchy. The folder class declares methods that fetch, append, copy, and delete messages. A folder object can also send events to component registered as event listeners. The store class defines a database that holds a folder hierarchy together with its messages. The stock class also specifies the access protocol that accesses folders and retrieve messages stored in folders. The stock class also provides method to establish a connection to the database to fetch folders and to close connection. Service providers implementing message access protocols IMAP 4, POP3, etc. start off by subclassing store class. A user typically starts a session with the mail system by connecting to a particular store implementation. Message composition and transport. A client creates a new message by instantiating an appropriate message subclass. it sends attribute like the recipient address and the subject and inserts a content into the message object. Finally, it sends the message by invoking the transport.send method. The transport class models the transport agent that routes a message to its destination address. This class provides methods that send a message to a list of recipient. Invoking transport.send method with the message object identifies the appropriate transport based on its destination addresses. The session class. The session class defines the global and per user mail related properties that defines the interface between mail enabled client and the network. Jakarta Mail system components use the session object to set and get specific properties. The session class also provides a default authenticated session object that desktop application can share. The session class is a final concrete class. It cannot be subclassed. The session class also acts as a factory for store and transport objects that implement specific access and transport protocols. By calling the appropriate factory method on a session object, the client can obtain store and transport objects that support specific protocols. Here you can see message, send a message. Message is connected to transport. Here submit a message. Transport is connected to network infrastructure. Network infrastructure is connected to store, and receive messages pass from network infrastructure to store, and store is connected to folders. Folders contain messages, and folders is connected to message. A code to send a plain text message can be as simple as the following. Now we are focusing on Jakarta Mail abstract class layer. The abstract layer declares classes, interfaces, and abstract methods intended to support mail handling functions that all mail systems support. API elements comprising the abstract layer are intended to be subclassed as and extended as necessary in order to support standard data types and to interface with message access and message transport protocols as necessary. As an example, we can consider the package Jakarta.mail. The Jakarta Mail API provides classes that model a mail system. The Jakarta.mail package defines classes that are common to all mail systems. The Jakarta.mail.internet package defines classes that are specific to mail systems based on internet standards such as MIME, SMTP, POP3, and IMAP. The Jakarta Mail API includes Jakarta.mail package and sub packages. This package is in the module Jakarta.mail. As an example too, we can consider these code segments. This is to send a plain text message. The class session, the session class represent a mail session and is not subclassed. It collects together properties and defaults used by the mail APIs. A single default session can be shared by multiple applications on the desktop. Unshared sessions can also be created. The class session is in Jakarta.mail package. As an example 3, we can consider this in the environment with the WebSphere application server. This is to enable the Jakarta Mail 2.0 feature at this element declaration into your server.xml file inside feature manager element. Actually, the environment is here WebSphere application server Liberty. As example 4, we can consider this one. This is in Open Liberty. This is to send an email and to receive email from application. You can call the Jakarta Mail libraries in any application that runs on the server to send and receive emails. Create a Jakarta.mail.session object by adding and configuring mail session. Mail session element here. To enable the this configuration, in addition to enabling the Jakarta Mail feature, you must also enable the Java naming and directory interface JNDI feature in your server.xml file. This example mail session is configured so that it can be used for both a simple mail transfer protocol SMTP and internet message access protocol IMAP. After you configure the mail session element, the mail session is created and injected by using JNDI. JNDI. The name of the WAR file is example mail, the class name is SMTP sender, and the name of the Jakarta.mail.session object is Gmail SMTP session. If you use the standard JNDI context, Java colon comp/env/mail.mails/gmail SMTP session, specify the JNDI name attribute as JNDI name equal mail/gmail SMTP session. As an example, we can consider class messaging exception. The base class for all exceptions thrown by the messaging classes. This is in the module Jakarta.mail and package Jakarta.mail. Now we are focusing on internet mail implementation class layer. The internet implementation layer implements part of the abstract layer using internet standards RFC 822 and MIME. Here you can see MIME message object hierarchy. Here the message, you can see the message here and message here. Get from method returns address of message sender. Get subject method returns message subject. Get content type method return for example multipart / mixed. In message get content method return multipart. Multipart consists text, image, multipart. Here in text get count returns for example 3, and in multipart get body part returns body parts. You can see body part here, and in body parts get content type returns for example text plain, and here get content returns message text here. Here get data handler returns data handler. Use the data handler methods to access the image. Here get content multipart returns here multipart, and get content returns multipart. Repeat with multipart as before. As an example, we can consider this package Jakarta.mail.internet. Classes is specific to internet mail systems. This package supports features that are specific to internet mail systems based on the MIME standard RFC 2045, RFC 2046, and RFC 2047. The IMAP, SMTP, and POP3 protocols use MIME messages. As example 2, we can consider this code segment. Here the class MIME message This class represent the MIME style email message. It implements the message abstract class and the MIME part interface. This is in the module Jakarta.mail, and this is in the package Jakarta.mail.internet. As an example 3, we can consider this property mail dot here the property mail dot mime dot address dot strict. The mail dot mime dot address dot strict session property controls the passing of address headers. By default, strict passing of address headers is done. If the property is set to false, strict passing is not done, and many illegal addresses that sometimes occur in real messages are allowed. The type of the property is Boolean. As an exception example, we can consider class pass exception. The exception thrown due to an error in passing RFC 822 or MIME headers, including multipart bodies. This class is in package jakarta.mail.internet. As an error example, we can consider this one, the property mail.mime.multipart.ignore missing end boundary is set to false. Normally, when passing a multipart MIME message, a message that is missing the final end boundary line is not considered as an error. The data simply ends at the end of the input. Note that messages of this form violate the MIME specification. If the property mail.mime.multipart.ignore missing end boundary is set to false, such messages are considered an error, and messaging exception will be thrown when passing such a message. The type of the property mail.mime.multipart.ignore missing boundary is Boolean. Now we are focusing on IMAP POP3 NNTP implementation layer. IMAP POP3 NNTP implementation layer. As an example, we can consider this one, session.getStore IMAP here. The client can override the session defaults and access the store or transport object that implements a particular protocol. Here IMAP is there here. As an example 2, we can consider package com.sun.mail.imap. An IMAP protocol provider for the Jakarta Mail API that provide access to an IMAP message store. Both the IMAP4 and IMAP4 revision 1 protocols are supported. Refer to RFC 3501 for more information. The IMAP protocol provider also supports many IMAP extensions. Note that the server needs to support these exceptions, and not all servers do. In order to support the IMAP provider, You can query the server for support of these extensions using the IMAP store has capability method. Using the capability name defined by the extension, see the appropriate RFC after connecting to the server. This package is in the module Jakarta.mail. As an example 3, we can consider this code segment. Here the property mail.imap.port, the IMAP server port to connect to if the connect method doesn't explicitly specify one. Default to 143. The type of this property is int. As an example 4, we can consider this one. Here is an example of meta-inf/javamail.default.providers file contents. javamail.providers and javamail.default.providers resource files specify the stores and transports that are available on the system, allowing an application to discover what store and transport implementations are available. The protocol implementations are listed one per line. The file format defines 4 attributes that describes a protocol implementation. Each attribute is an equal separated name value pair with name in lowercase. Each name value pair is a semicolon separated. Here the protocol attributes, names are assigned to protocol, for example SMTP. Type, valid entries are store and transport. Class name that implements this protocol. Vendor, optional string identifying the vendor. Version, optional string identifying the version. Here the class IMAP store. This class provides access to an IMAP message store. The class SMTP transport. This class implements the transport abstract class using SMTP for message submission and transport. As an exception example, we can consider class referral exception, a special kind of authentication failed exception that indicates that the reason for the failure was an IMAP referral in the response code. See RFC 2221 for details. This is in package com.sun.mail.imap IMAP. This is in the module Jakarta.mail. As an example 5, we can consider package com.sun.mail.pop3, a POP3 protocol provider for the Jakarta Mail API that provides access to a POP message store. Refer RFC 1939 for more information. The POP3 provider provides a store object that contains a single folder name inbox. Due to the limitations of the POP protocol, many of the Jakarta Mail API capabilities like event notification, folder management, flag management, etc. are not allowed. The corresponding methods throw the method not supported exception. This package is in module jakarta.mail. The POP provider supports POP3 UIDL commands. You can use it. You can use it as follows. The class POP3 folder, a POP3 folder that only be in box. As an example 3, we can consider this code segment here. Property mail.pop3.port, the POP3 server port to connect to. If the connect method doesn't explicitly specify one, default to 110. The type of this property is int. As an example, exception example 2, we can consider this one, messaging exception thrown for failures in method public java.lang.string get uid message msg in class POP3 folder. As an example 8, we can consider this typical content of java.mail.address of a JavaMail.address.map file. Here RFC822 is equal SMTP and news NEWS equal NNTP. News equal NNTP. This is end of my presentation. Thank you very much for watching it.